In this video for the Mine Simulator TMS, we'll be discussing blasting, how blasts are initialized within the simulation and how blasts are specified in the simulation. To enable blasting in TMS, you go to the Operational Data tab from the main menu, and then there's a Blasting tab to enable you to specify blasting. The purpose of blasting in TMS is not to emulate blasting as such, but more to generate the impact blasting has on mobile equipment, diggers and trucks, etc. So what the simulation does, it actually monitors the amount of broken rock in front of each digging unit. And when that amount of broken rock falls below a specific level, the simulation will signify that a blast needs to occur near this digging unit. So to specify blasts in TMS, you first nominate your preferred or your blasting window. So in this particular example here, blasts will occur between 12 noon and 1 o'clock in the afternoon, and that's when 80% of the blasts occur. And then between 1 o'clock and 3 o'clock in the afternoon, 20% of the blasts occur. So you can nominate when blasts occur and when you're not allowed to do blasting in the mining operation. You can also nominate whether they start at the hour. So in this particular case, if we say yes here, that means if there's a blast to happen in the mine, it's going to happen at 12 o'clock. Or it's going to start preparing for a blast at 12 o'clock. But in this particular case where we say no, that means these 20% of these blasts will occur somewhere between 1 o'clock and 3 o'clock in the afternoon, depending on how you want to set it up. So what happens, the other things you can nominate. So what happens when a blast occur? If a digger is nominated where I need to have some blasted rock in front of me, and we're in a blasting window, what happens is a blast warning is notified. Everybody that a blast is about to happen. An access restriction is placed around the diggers requiring a blast. So this is an exclusion zone, it may be 500 metres or whatever happens. And then what happens when that exclusion zone is up, it actually puts virtually cones across the haul road, and no trucks can enter the restriction zone. So any trucks heading for that digger and they've got nowhere else to go, they'll actually go down to where the cones are crossed and park virtually in front of where the cones are parked, or they'll go to a park up area, whichever is available. And now when there's no operational trucks in the blast area, i.e. the diggers have already loaded the last trucks, the digger will start to walk away from the mine face using a time which is specified in the distribution. And when there's no trucks within the restricted zone and the affected digger has walked away from the mine, the actual blasts occur. And then if everything's okay at the end of the blast, the diggers will move back into the mine face, walk back in, and the access restriction zone is removed, and then the trucks can re-enter these zones to start loading. The simulation also, you can specify what percentage of blasts misfire and then what happens with the misfires. So some of the parameters you can set with your blasting is not only your blasting window, you can set things like the maximum number of blasts that occur in any one blast event. So you may be if there's two diggers requiring a blast, you can say only one can occur, or you can say, well, two required, we'll put blast zones around both of them and we'll actually blast in front of both diggers at the same time. So this is a global access restriction you put around the blast. And once again, this is a global one, so in this case it's 300 metres, but you can actually change it based on your mine block. So some mine blocks where you want to blast them, you may have to put a larger exclusion zone around them, or a smaller one. This is a distribution, goes in a distribution list. So it's a variable how long it takes to move the digger away before the blast, and then the time to move the affected digger after the blast, move it back to the face. And then this is another distribution which says, depending on the blast, how much broken rock is being generated for the digging units from that blast. So that can be a variable once again using a distribution. And then the duration of the blast, how long from when we say, you know, ready to blast, how long it takes to actually do the blast and then give the all clear. And this is where you can specify the number of blasts that actually misfire. And then if they do misfire, then you can go down to here and actually change the time for doing the extra blasts and what happens when you do the refire virtually, and the percentage of material made available by doing the refire. So this is how in the simulation we do blasting. Once again, it's not about the blasting as such, it's more about the impact it has on production and on trucks and stuff like that. So that's about it as far as blasting goes. It's not a precise emulation of blasting, but the whole idea is that when you do your validation of your simulation, the amount of time that actual mobile equipment is impacted by blasting should be similar or the same as what the simulation is generating as far as the impact of blasting is having on in the simulation. So that's blasting in TMS. Thank you.